Welcome back to the deep dive. We are trying something a little different today. Usually we grab a stack of articles on a trending topic, AI, climate tech, whatever is in the news, and, we synthesize them.
Right.
But today we're zooming in on a single artifact. It's a blog post published just today, January 23, 2026, from a site called keonmeng.org.
And honestly, if you just glance at the title, you might wonder why on earth we picked it. It's called Notes on Haskell Programming, Part 39. First step in refactoring CLI parsers for testability.
Yeah, I have to admit, when I first saw that in the queue, I thought, okay, this is going to be dry. It sounds like the kind of thing you only read when your compiler's screaming at you and you're desperate for a fix.
It does. It's incredibly niche. But the reason we're here is that if you look past the syntax, we aren't just looking at a coding tutorial. We're looking at a worldview.
Yeah.
We're looking into the mind of someone who calls himself an old software plumber.
That specific phrase, old software plumber, really stuck with me. Because as we dug into this, we realized this author, Ang, applies the exact same rigorous debugging mindset to his Haskell code as he does to, well, everything else in his life.
And we mean everything. We're talking about a massive archive of notes on gardening, fish keeping, photography, diet. It's really a masterclass in what it means to be a tinkerer in the modern age.
So our mission today is twofold. First, we do need to actually understand the code he's writing about. There's a specific, genuinely brilliant insight here about how to make software testable that applies to pretty much any language, not just Haskell.
We're going to unpack that aha moment.
Exactly. And then we're going to step back and look at the sidebar, quite literally. We're going to see how he uses that same engineering brain to propagate ferns and fight algae.
Because it turns out debugging a command line tool and debugging a fish tank are surprisingly similar activities.
If you have the right mindset.
So you have the right mindset.
Okay, so let's start with the hard skills, though. We need to set the context.
Right.
The project he's working on is a console application called XS2Book.
Right, it's a command line tool. And Ang is trying to do something that sounds simple, but is often a nightmare in practice. He wants to add the very first test to this application.
Which is such a classic scenario for anyone who builds things. You build a prototype, you hack it together to get it running, and it works. But it's a house of cards. Now, you want to make it robust.
You want to verify it automatically.
Right, and that is where he hits a wall.
He shares the before code, lines 1 through 12. He shows us a function called parse-CLI. Now, looking at it, it's short, it seems harmless. But for a tester, this function is a trap.
Explain that, because when I look at parse-CLI, I just see him setting up some options, like what arguments the user can type in, and then running it. What's the problem?
The problem is that parse-CLI is acting like a black box that refuses to be opened. It does two things at once. First, it defines the rules. Here's what the arguments should look like. But then immediately, right there in the same function, it calls extandr parser.
And a kick parser is the trigger.
Right. Exec parser is the function that reaches out to the real world. It grabs the actual command line arguments from your operating system and executes them.
Okay, I think I see the issue now. If I'm writing an automated test suite, I'm not sitting there typing commands into a terminal manually. I'm running a script.
Exactly. If you want to test that function as it stands, you can't just say, hey, function, what happens if I hypothetically pass in the argument help? Because the function isn't listening to you, it's listening to the operating system.
So you'd have to launch the whole program.
The whole thing. You'd have to launch the program in a shell, pass fake arguments, capture the text output. It's incredibly messy.
It's like trying to test if a car engine runs smoothly. But the only way to do it is to put the engine in the car and drive it into a wall to see what happens.
That is a perfect analogy. And if the engine explodes, you crash the car. You don't want to test by driving. You want to be able to put the engine on a diagnostic stand in a garage.
And a controlled environment.
Yes. You want to hook it up to sensors. You want to isolate the logic from the execution.
So let's look at the after code. This is the refactor. He takes the logic between lines 13 and 17 in the new version, and he moves it.
He performs what's called a logic extraction. He takes the definition of the parser, the instruction manual, if you will, and he wraps it in its own standalone function called argparser_info.
And crucially, on line 03, he exports that function.
That export is the game changer. By exporting argparser_info, he allows the test suite to import just the rules. The test can now say, okay, I have the rules here on my workbench. I'm not running the program. I'm just looking at the rules.
If I were to feed this argument into these rules, would it work?
Precisely. It separates the what from the do, and notice how small the change is. It's just moving 5 lines of code. But architecturally, he's moved from a monolithic script to a testable system.
There's also a subtle detail in the import section on line 06. In the old code, he listed every single function he was using. In the new code, he just imports the whole module, and he has this great little aside.
Oh, yeah, I love this part.
He writes, "Since we've spent over so many posts discussing this code base, we should be comfortable enough with Haskell to recognize these parts."
That signals mastery, doesn't it? When you're learning a language, you lay out every tool on the table so you don't lose them. Here is my hammer, here is my wrench.
You need to see them.
But when you know the tools, you just reach into the tool box without looking. He's telling his readers, look, we live in this environment now. We can move faster.
Speaking of the environment, we have to address the technical concept he highlights as tricky. I think this is where a lot of people might get lost, so let's break it down. He talks about the type signature, parser info, IO.
Yes, the box and the apple.
That's the analogy he uses. I found it really helpful. He calls parser info a box. For those of us who aren't deep into functional programming, help us visualize this. This is about parameterized types.
It is. Think of parser info as a container, or maybe better, a template. You can't just have a generic container in Haskell. It's too vague. You have to have a container of something.
A bucket of water.
Yeah.
A crate of apples.
Exactly. The container defines the shape, but it needs content to be a complete type. So parser info is the crate. It's the structure that knows how to parse things.
And IO is what's inside the crate.
Right. That's the apple.
Okay, let's unpack the apple. IO. I know IO stands for input-output. But in functional programming, that means something very specific, doesn't it?
It does. It's not just data in, data out. In a pure functional language like Haskell, most functions are like math equations.
Yeah.
2 + 2 = 4. It doesn't change anything in the universe. It just is.
No side effect.
No side effects. But I/O represents an action that has side effects. It changes the state of reality. It prints text to a screen, writes a file to a disk, or, launches a missile. It leaves a mark.
It modifies the world. And what about the empty parentheses? That looks like a typo to the uninitiated.
That is called unit. It's a placeholder that effectively means no useful data is returned.
So if I put those together, I/O is an action that changes the world like printing to the screen. But it doesn't hand me a receipt or a number when it's done.
Perfect description. Think of it like a light switch. You flip the switch, that's the I/O action. The room gets bright, that's the side effect. But the switch doesn't hand you a slip of paper saying light is on.
It just does the thing and finishes.
That's I/O. So parser info, I/O, represents a set of rules, the box that explains how to trigger these world-changing actions, the apple.
You've got it. It's a parser that results in an action.
And what I found really endearing here is that Ang admits he used to find this confusing. He says he used to see parser info on I/O as two separate things sitting next to each other.
Instead of one specialized type.
Right. That is a moment of vulnerability you don't always see in technical writing. Here is this old software plumber, clearly experienced, admitting that his mental model had to evolve. He's showing us that even he is still learning how the pipes fit together. He realized the box and the apple fuse into a box of apples.
And that concept of continuous learning, of constantly refining your mental model, is the perfect bridge to the rest of his website. Because if you think Notes on Haskell Part 39 shows dedication, you have to look at the sidebar.
The sidebar is, frankly, it's overwhelming. In the best way.
I just want to read some of these numbers out because it really sets the scale of this guy's tinkering. We are analyzing a Haskell post, but under everything else we have Notes on Photography, Part 226. Notes on Fishkeeping, Part 179. Notes on Dieting, Part 113.
And the big one.
Notes on Gardening, Part 785.
785 entries on gardening.
It's absurd. And these are active. Just in January 2026, alongside this Haskell code, he's posting about the blackbeard algae, revisiting the butterfly pea, and the cost of organic look in photography.
This is why I love the term software plumber that he uses. It feels so accurate.
How do you mean? How does plumbing connect gardening and coding?
Well, think about what a plumber actually does. They deal with systems. They deal with flow, pressure, leaks, blockages. A plumber understands that if the pressure drops in the kitchen sink, it might be because of a valve in the basement.
It's all connected. It's systems thinking.
Exactly. Whether he is refactoring that Haskell code to make the data flow logic testable, or he's figuring out why his fish tank has algae, he's using the same diagnostic process. He's isolating variables.
Well, I noticed that specifically in the fish keeping section. He has a post from January 16th about building a custom sump. A sump is a filtration system, right?
It is. It's literal plumbing for a fish tank. But look at how he writes about the plants, too. He has titles like The Upward Growth of Zinnia or The Transition of Submerged Leaves. He isn't just looking at a flower and saying, oh, that's pretty.
No, he's analyzing the growth parameters. He's looking at light levels, flow rates, nutrient intensity. He's debugging the garden.
Yes. There is a post from January 4th, 2026 titled, Why Nothing Grows Under the Rain Tree. That reads exactly like a bug report.
He's filing a ticket against nature.
In a way, he is. Think about how most people garden. If a plant dies, they shrug and say, I guess I have a black thumb. They treat it as a random event.
Or a personal failing.
Right. But a tinkerer, a plumber, asks why. Was it the shade, the soil acidity, the root competition? He investigates the failure just as rigorously as he investigates a compiler error.
Speaking of which, I saw a Python post sandwiched in there from January 8th. Type error. Type object is not subscriptable.
C. A literal error message next to a biological error message. To him, they're all just data points in the system of his life. This blog isn't a diary, it's a laboratory notebook.
The consistency is what really blew my mind. I went back and checked the archives. In 2025, he had 730 posts. In 2024, 732 posts. He is posting basically twice a day, every single day, for years.
That really challenges our idea of expertise. We tend to think experts are people who have these lightning bolts of genius. But looking at Ang's work, expertise looks a lot more like simple persistence.
It's just showing up.
It's the result of writing Notes on Gardening Part 1, and then showing up the next day for Part 2, and eventually, inevitably, hitting Part 785.
It actually connects back to that Haskell concept we just talked about, I/O.
The unit type, how so?
Well, remember, I/O is an action that returns a unit, no data, but has side effects. Writing a blog post about decoding duckweed, which he did, doesn't give you a monetary reward. It returns a unit. But the side effect is that you understand duckweed better. The side effect is that your observation skills improve.
That is a profound way to look at it. The value isn't in the return type. It's in the execution. It's in the doing. And if you look at his projects list, he has this week in review, this month in review, this year in review.
He is constantly running a feedback loop on his own life. He's refactoring his life, just like he refactored that parser.
Precisely. He looks at his week and asks, okay, this process, my diet, my photography workflow, it's a bit of a black box. It's not optimal. How do I extract the logic? How do I make it testable? How do I improve it?
It really pushes back against the trend of hyper-specialization, especially in tech. We're pushed so hard to narrow down. I'm a React developer. I'm a back-end Postgres specialist.
And this guy is writing about Elixir, Python, Go, Rust, and making modular camera systems. He's a generalist tinkerer. And I think there's a strong argument that this makes him a better programmer.
It's cross-pollination.
Yes. Because he understands the organic look in photography, he might approach image processing code differently. Because he understands the slow, chaotic growth of ferns, he might have more patience with a difficult code base.
And notice how he shares the before and after code in the Haskell post. He's showing his work. He does the same with the fish keeping. He talks about the blackbeard algae. That's a plague for fish keepers.
It's ugly. It ruins the tank.
But he writes about it. He doesn't just show the Instagram perfect tank. He shows the algae.
That transparency is so refreshing. It makes the note format make so much sense. These aren't polished essays meant to go viral. They are notes. Here is what I saw today.
And that lowers the barrier to entry. If you think you have to write a definitive essay on Haskell, you'll never start. But if you just write, Note 39, I learned about this type constructor today, you can keep that up for a decade.
It's the unit again. Small atomic actions.
Exactly. You know, looking at the January 2026 list again, there's one that jumps out at me. The cost of organic look. It's under photography. And I feel like that applies to his whole philosophy.
In what way?
Well, the organic look usually implies imperfections, grain, texture. And his blog feels organic. It's not a slick corporate dev blog. It's text-heavy. It's personal. It's full of these specific weird details like parboiled rice and tubifex worms.
It feels human. In an age where so much content is generated or polished to death, this feels like a human being tinkering in their garage or their garden or their terminal and just saying, look at this cool thing I found.
And connecting it back to the Haskell code one last time.
Yeah.
We started with a function that was impossible to test because it was doing too much at once. It was a black box.
Right.
And the solution was to break it open, separate the parts, and understand them individually.
Yes.
I feel like that's what he's doing with his time. He's not just letting his life be a black box where days just happen to him. He's parsing it. He's separating gardening from dieting, from coding, and he's examining each one, tweaking the parameters and seeing what happens.
That is the ultimate takeaway here. You can live life on autopilot, which is like X cursor running blindly. Or you can export the logic, you can examine your habits, you can write notes on whatever it is you do, you can take control of the configuration.
So we came for the Haskell, but we stayed for the Zen of the tinkerer.
As we often do, the code is just the medium, the thinking is the message.
I love that. So here's what we want to leave you with today. We talked about notes on gardening part 785. That represents nearly 800 days of paying attention to plants, of noticing the wind, the soil, the growth.
That is a massive amount of directed attention.
So our provocative thought for you is this. If you had to start a notes on series today about something in your actual life, what topic would you be able to write 700 entries about?
And not just what could you write about, but what would you want to pay that much attention to?
Exactly. Because if you can't answer that, or if the answer is something you don't actually care about, what does that say about where your attention is going?
It suggests your parser might need some refactoring.
Ooh, nice callback.
I try.
Check out keonneng.org if you want to see what 15 years of consistent tinkering looks like. It's really inspiring stuff. Thanks for diving deep with us.
See you next time.